All right. All right. Okay. Good. Very morning. Okay. Now afternoon to you all. I'm sorry because I have the PhD evaluation just now, so I delay the class for 1 hour. All right. However, our time is from 11 to 1, so we have a time to go for chapter 4. Right. Chapter 4. So now I'm sharing the QR code. Please scan, and I'm also sharing the Padlet, all right, where you can answer the question. All right, some of you now, okay, answering, okay, still writing, and together with us is Enjia Shing, okay, Enjia Shing. I invite, and I'm also inviting some of you. If you want to join me, let me know. All right, so I just want to chit chat with you all right? So can we start? All right, so the question now, can we start? All right, so when we have the Padlet, two questions here, when you are using your correct name, that is to classify your attendance today. All right, so now let's I share with you. Now let's I stop sharing. Okay, NG, I'm sharing now. All right, so I want to share at the my class today. Okay, is a chapter 4. um, okay, my class yesterday, right? Yesterday we learned, okay, let's we, okay, confirm sharing yesterday what we learned, okay, let's we focus yesterday class, okay. Yesterday, okay, we learned about curve fitting. We are learned two methods, quadratic least square method and linear least square method. So linear least square method, you okay using a matrix to represent the linear okay form to create a linear function, all right, for a data given, all right. So in this case, okay, you try how to generate the linear least square method, So we are using, okay, minimizing the square error. Okay, the error is between data and the y equal to a plus bxi is a linear function to represent the matrix. So this is a matrix that you are going to develop after minimizing the square error from I equal to 1 up to n. So the summation, okay, is very important when you want to find the value using calculator. I just said that calculator. And then yesterday we are using arrow. We no need to calculate every point. We just use arrow to fulfill the value of summation xi, summation yi given in the question, summation xi squared, summation xi yi, okay, in the matrix A u equal to f of the linear least square method. All right, so now, okay, towards the end, you can get what is the value A and B to represent the linear for this data is y equal to A plus bx. Alright, so now we continue our journey using quadratic least square method because we believe that to make good, okay, or accurate result, we represent the graph in quadratic or in parabolic. So in this case, the same step, we are minimizing the square error, okay, del S over del A, okay, the first derivative as respect to B and first as respect to C. So we develop the matrix form, okay, by express the first derivative as respect to A, B, and C. And let's we develop the matrix. The matrix is a 3 by 3. All right. So we need to find what is the value summation x cubed summation, okay, x squared, okay, summation x squared yi. So in this case, we need to use a calculator. All right. When we use a calculator, you need to find var. You need to use equation whether linear or quadratic. We need to use sum and reg equation. All right. So that is we talk. Okay, we complete with the example. Okay, of the linear system. Okay, and then okay, the example here shows that how you transform, okay, the data into the table, and then you don't need to write all the values, but you need just to find the summation xi, summation yi, summation xi squared, summation xi power 3, summation xi power 4, and so on. All right. So we know how to find A, B, C, the parameter for quadratic least square method, y equal to A plus bx plus cx squared. All right. So we already done this process. Okay, now let's we continue to this topic. Is the last part of the chapter 4 we call as a linearization. Right? Let's we go. Right? What is a linearization? So I stop sharing. Okay, I want you to go to e-learning. All right, you go to the e-learning. Where is my e-learning for chapter? Okay, e-learning attendance, quadratic. Okay, linearization. Let's we go to the e-learning UTM. Okay, go to the e-learning. The course. Okay. Okay, very slow here, even though you can go to the Telegram where I post, okay, I post the e-learning itself, all right, okay, the e-learning. Okay, in the e-learning, go to the Telegram, I post the video, I post the notes, okay, where is the notes? Okay, I stop sharing, I share the notes, okay, in the PDF file. Okay, you can go to the PDF file, chapter 4. All right. Okay, now I'm sharing chapter 4. There is exercises. I will address you to do this after the class. Okay, exercise 4.2. Now we go to the linearization. Okay, what is a linearization? Go to page, in this case, we are in page 13. Okay, page 13. All right. So now, what is linearization? Linear. Okay. How we do the linearization? Okay. So now, okay, I already prepared the video. Okay. I share with you the video. Okay. I'm stop sharing. I share with you the video. Mm-hmm. All right. Okay. About the linearization. All right. I'm going to capture a different screen in this project. Okay, I share again. Stop sharing. Okay. All right. So this is a linearization. Okay, you can go to the YouTube. Okay. So let's I make it bigger. All right. So let's I look at the visualization. It's very good now. Okay. What is a linearization? Okay. Uh, we start with the linearization. Linearization is how the way you transform from the nonlinear equation to the linear form. Okay, from the nonlinear equation to the linear form. Right. For example, y equal to c exponent dx. Okay, transform to y equal to a plus bx. So how to do that? Right? How you transform from the exponential function, which is not linear, to the linear form. How to do that? All right. So in this case, okay, there are one way to do is by take ln for every both part. For example, you know that ln A B is equal to ln A plus ln B, right? So when you choose ln A, ln, okay, the process when you choose ln Y on your left hand side, and then ln C exponent dx on your right hand side, and then apply the formula of the ln function, you will get ln C plus ln exponent dx. However, we know that ln exponent, okay, ln exponent is equal to 1, right? Because the opposite of the exponent is a ln, the ln is opposite of the exponent, so they will be equal to 1. So you can get the answer is ln y equal to ln c plus dx, okay, times 1. Okay, so this is what we do. We take ln for every both side, okay, to make sure that the equation is a linear. So what is a y bar? Y bar is a ln y. What is a? A is a ln c. All right. What is d? D is a b. Okay, d is a b. So this is how we transform from the exponential function to the linear form. All right. So now, okay, I stop here. I want to share with you, okay, the notes. Okay, let's we go to the notes. Okay, I've stopped sharing. I share with you the PDF file. Okay, let's we go to the PDF file. Okay, you can see here. Okay, go to page, if you can go to page, okay, let's I make sure that I'm sharing with you the PDF file, okay, on Gxing. Okay, go to the page, okay, you can get from the e-learning, okay, the page, okay, let's I move down, page 14. You can see just now, okay, we just finished y equal to c dx, okay? So we can get the linear is a ln y ln c plus dx, where a is a ln c and d is a b when we expose to the linear system y equal to a plus bx. So this is one of the example. So now my question, okay, let's I go to this question, right? How to make sure that we can expose this into a linear system? How to do that, right? So can you write, okay, how you can expose, okay, how you can transform this equation to the linear? So my question is how to transform, okay, into linear, okay, into linear form. All right, please do it. Okay, you can see here a is equal to ln c, and then d is equal to negative b, and from here you can see that y is a ln y over x. Okay, all right, so this is one of the example how you transform from exponential function to the linear form, right? So this is we need to express here because you need to know how to transform from nonlinear to linear. All right, so now let's we go for this one. Y equals c dx. Okay, in this case also you can find you can take ln for every both part. You can get ln y, ln c plus d ln x. Okay, where y is a y, big Y is a ln y, a is a ln c, and b is a d, and x is a ln x. Okay, so that is the way how we transform the nonlinear to the linear form. All right, so you can go to page 14, how we get the solution to the process of the transformation from nonlinear to linear form. All right, so now I stop sharing. I want to share with you the next part. Okay, let's we go to the next part. All right. Okay. Right. So and Jia Shing, let's we focus the notes. Right. Okay. So now when we go to this, you can see here. All right. You already transform the ln y is equal to ln c plus dx, where this is a linear form. Y bar is a ln y, a is a ln c, and b is equal to d. All right. So now let's we go to the example, because the next process, we want to apply into a data. The data we want to make it in linear, all right, in the linear form, and then we want to find what is the value for C, for D, by knowing A and B. Okay, now let's we have a data. In this data, you can go to the notes. I'm using the same data. X equal to 1.0, x1 equal to 1.2, x3 1.4, 1.6, 1.8, and 2.0. All right. The value of y is 2.1408, 3.2248, 3.7831, 5.996, 7.3299, and 10.1428. So this data is represented the exponential function. All right. So in this case, we need to transform the exponential function to the linear form y equal to a plus bx. All right. And then the second question, they ask us to find the summation of square error. You have to know the error is a difference between data and the linear least square method that you get from the previous, previous topic is a linear least square method. Linear least square method. So now we need to go through all the 3 steps. What is the step? The first is transform the exponential function to the linear form y equal to a plus bx. Means that to find C and D, you need to find A and B first. And then base, you know what is a y equal to ax plus b from the previous, least square, linear least square method. You can find what is the value A and B. After getting the value A and B, you know that, what is the value of C and D. All right. So now the extra part here is only transform nonlinear to linear form. All right. The rest you can go to the you can go the topic that we learned in the previous day here, on Sunday. All right. So now let's we continue. We know already the given exponential function to represent the data is a what's that? C exponent dx. So we learned already when we take ln for every both part, you can get ln c, ln y plus ln c plus dx. All right, and then we can find. We can represent. We can match that. Ln y is a y bar, ln c is a, and b is a d. Right. So now we have a data already. We do the linear least square method. Okay, we draw in the table. At the same time, press your calculator, insert all the value. I'm waiting you to insert the value. All right, so please insert the value. Okay, Ssce. All right, and then the rest of you, please press your calculator. All right, by using the data given. Okay, page 40. What is a summation 1? Summation 1, okay, you can go to the book, okay, linearization. Okay, in the books, okay, you can see that linearization in chapter, in the, in page, okay, come on, we go to page, we go to page, okay, 112, all right? Okay, 112, and then the data is 5, okay? I0, I1, I2 until I5, all right? So the data is given in the table before. You can see the data, all right? So this is the data. Okay, and then please, okay, insert in your calculator. So the summation I from 0 to 5 is 6. Okay, 1 plus 1 plus 1 plus 1 plus 1. Okay, plus 1. So 6. From I start from 0 to 5 is 6. All right. So now let's we continue this data. Okay, now unleashing, let's refocus, okay, to the notes here. Okay, so in this case, okay, we need to apply the linearly square method. Okay, we need to find the summation xi, summation yi, summation xi squared, summation xiyi that we learned in the previous lesson. All right. So you just insert the data. Be careful. What is xi, yi? I told you. Okay, you need to press mode 4 and then press the same thing that you learned before. Okay, is a variant. Find the linear, and then insert xi, yi, and then press variant to get the summation si, summation yi, summation si squared, summation siyi, and then press reg to find the value a and b. All right. So when you press, okay, try. Okay, I'm okay waiting you to press all the value. Okay, I'm waiting you to press all the value. Okay, and then don't forget insert the summation siyi into the matrix 2 by 2 of linearly square method, right? Don't forget, okay, because we want to find the value a and b. Because what? We want to find the value a and b. Right? From the calculator, you can get a is equal to negative 0.7262 and b is a 1.5215. All right. So in this case, okay, this is not the last, this is not the final result because our function is an exponential function. Okay, this is only a transformation uh, from the exponential function. Okay, this is a process of the linearization. All right. So in this case, come back to uh, the transformation process. Okay, where you get the value of a and b from the linearly square method, the matrix that you refer also linearly square method. Right. So continue to find what is a C and D. What is a C and D? All right, so now let's replace. We replace, okay, A as a negative 0.7262 is equal to ln C. All right. We replace, okay, D is equal to B 1.5215. So from here, when you said that ln C is equal to negative 0.7262, to get C, okay, you need to again take the exponential function for negative 0.7262. You need to take exponential function for every both part. Okay, exponent power ln C is C. Okay, you have to know that. Okay, is C is equal to exponent negative 0.7262, press your calculator, you will get 0.4837, right? So, okay, D, you have no need to do some adjustment because D is equal to B, right? And X is also not do adjustment for X bar. Okay, that is a similar. So now, okay, you get the original exponential function y equal to c exponent dx as a 0.4873 exponent 1.5215x. All right. So this is the way how to find, okay, the value of C and D from the linearly square method by find the value of A and B. All right. By find the value of A and B. Okay. Again, I'm stop here. What is a step, okay, to solve the nonlinear exponential function to the linear, okay, function using linearly square method? The answer is, the first step is transform. Okay, what is the first step? Transform the nonlinear y equal to c exponent dx to the linear form. Second, okay, use a data given and use the matrix of the linear least square method to find the summation A, summation x, summation y, summation xi squared, summation siyi, because we want to find the value A and B, okay, the linear form. And then the third step is change, okay, or get the value of C from A and get the value of D from B. All right. So this is the three step you need to remember. Okay. So this is a very easy because we learned already all the linearly square method. Just I spark to you how the way you transform from exponential function, not linear, to the linear function. All right. So when we talk about error, what is error? Okay, error is a exponent EI squared. Is a difference between the data and the linearly square method that you get from, okay, from the equation, the matrix. Okay, all right. So now we know already y equal to c exponent dx is a data, okay, that you get from the linearly square method. Yi is a data given in the question, early question. And then when you minus between both data from the linearly square method and from the data given, you can see here when you square, okay, when you square all the error, for example, 2.12150 minus 2.1408. Okay, YXI you need to do one by one, yeah, until Y5. Okay, YI is given in the table. So you need to use the standard exponential function that you get from the linear square method. So when you minus and then you square, you get the error is 0.3503. It's considered a big error because why? Because you are using linear least square method. You are using linear least square method, right? So maybe you can have any alternative, okay, by okay, transform the equation nonlinear to the quadratic form, to the quadratic a plus bx, a plus bx plus cx squared, if you can do. So you can reduce the error, the summation error. All right. So in this case, it's very easy. Okay. For this lesson, we just have one extra case step. What is that? Transform from the nonlinear to linear form. Okay, to the linear form by using the linearization. Okay, for example, y equal to c exponent dx to y bar equal to a plus bx. All right. So there are so many examples here. Okay, I share with you. Okay, stop sharing. Okay, now I want to share with you the PDF file again. Okay, you can see here, there are so many, okay, non-linear, for example, y equal to x divided by c dx. All right, so you can also transform to the linear. Y bar is a 1 over y. Okay, a is a d. Okay, b is c, and x is 1 over x. All right, so you generate the linearly square matrix, okay, form to find what is a and what is a b, and then transform to the original y equal to a plus bx after knowing the value of a, and then after knowing the value of c and d, you will get the error, the summation error, whether you can reduce it or you want to maintain, depends on the you want to use linear or you want to use a quadratic. But in case, okay, the title here is a linearization. Okay, this one is a table for transformation. Since we are learning about the linearization, we just focus on the linear form. Okay, the linear form, y equal to a plus bx. So the calculator that you need to press is a linear. All right, so now I have Ng Xing. If you can ask a question through the chat, or others, you can ask any question, okay, through the chat. Okay,
Doctor,
any question? Yes.
about the decimal place for the non-linear, right? After
Mm.
we do the answer for that, right, we all make the answer to four decimal place, or it's just all the
Yes.
examples is on four
Yes.
decimal place.
Okay, okay, you need to follow the instruction from the test 2. If the test 2 requests to use three decimal places, you press mode fix 3. But if they ask you to use mode fix 4, 4 decimal places, you press mode fix 4. So you need to follow the question. In this
Okay.
case, you can see here, okay, in PDF file that I giving you the example. Okay, there are so many examples here. All are calculated in the 4 decimal places. Okay, so you use mode fix 4. All right. The important here, okay, if you wrong, you have I give you a marks because the answer is plus minus 0.001. Okay, I give you the plus minus 0.001 because some of you, okay, they not press the mode fix 4, they press mode fix 3 and so on. So this is a mistake lah. But I put plus minus 0.0001, for example. Yeah. Okay, thank you, NG Shing. Right.
Thank
So
you, doctor.
the important I want to express here, how, okay, you put one step by transform the nonlinear to linear, and then follow, okay, what we learned in the previous section, lesson. Okay, we are using linear least square method, and then when you press your calculator, press linear. All right. Okay, press step linear, not quadratic. All right, because the next, okay, we are using linear least square method. All right. So this is one good way. So what is a linearization? Linearization is a process you transform. Okay, you transform the data, and then the nonlinear equation y equal to c exponent dx, for example, to the linear form y equal to a plus bx. All right, and then you need to follow the process of the linear least square method to get a and b. After getting a and b, right, you need to go to the process of getting the value of c and d. Don't forget, you need to match. What is a? A is a ln c. What is a b? B is a d. You need to match, okay, match from the previous step. And then to get the error, okay, what is error? Error in our case is a difference between the data given, okay, and then the exponent, the yi, the data given, and then the yi comes from the y equal to c exponent dx. Okay, you need to find all the value and then get the error. Error is a subtraction between data and non-linear. Okay, non-linear y equal to dc plus exponent dx. All right, so this is the answer. 0.3503 is very big. So you need to have another method to make it small. Okay, maybe you need to transform to the quadratic, for example. Yeah. All right. So now, any question? Okay, do you have any question? Okay. Come on. Okay. I request you any question. Okay. Since there is no question, what should you do? Okay. I stop sharing. All right. I want you to share. I want to share with you one page here. Okay, what is that? This one. All right, I share with you now. Some of you already answered the question. Thank you very much. Put your name. Okay, okay. Please write a correct way. Okay, how? What is a linear least square method? Okay, Ong Shui Lee said that linear least square method is a push to find the best linear straight line for a set of data by minimizing the sum of square error. Very good. All right, so now anonymous name. Okay, anonymous name. I'm not sure who are giving this. Okay, oh, Raja or Faleh. Okay, go front. Okay, come on. They said that linear least square method is a set is to insert data into linear line result from the linear equation considered with the every data given. All right, so this one also accepted. Let's we go to the Kisharo, okay, Subramaniam. Linear least square method is a procedure of fitting the best straight line of the linear equation. Very good. Okay. All right. So now let's we go. Okay. If I can share with you another survey here. Okay. That I stop sharing. I go to another share screen with you. Is what is quadratic least square method? So now I'm sharing with you. Okay, let's I focus here. All right, you can find here. Okay, Calvano Rolanda said that it's a process of finding the equation of the parabolic as the best fit of a set of data. All right, and then Krishna Rao also said that quadratic is a fitting all the data into a curved line. It's a parabolic line which consider every single data provided. And then Ong Shui Lee said that quadratic is a push to find the quadratic equation, quadratic function for a set of data by minimizing the summation of squared error. Very good. And then Kwa Jin Z said that linear, okay, least square method is a procedure of fitting the best straight line linear equation y equal to a plus bx by minimizing the sum of the square. Okay, good. All the answers good, but I want to asking a question whether you go to the exercise or not. So I'm worried that one. All right. So since we have, we stop sharing and then we share another part. All right. That is come on. We go to the PDF file. All right. There is exercise 4.3 here. Okay, this is a time for you to try to answer the question. Okay, Anjishi, I stop. Okay, I go to the specific question. All right, so you can see here, you are given x0, x1, x2, x3, x4. Okay, meaning that summation 1 from I equal to 0 up to 4 is 5. So you need to change y equals c exponent dx into a linear, okay, into the linear y equal to a plus bx. And then you calculate the squared error. And then which is better? They ask you which is better. Okay, A or B? Y equal to xd to fit the above using the linear of the data. Alright, where we said that x is equal to ln x and y is equal to ln y. Which is better? You need to find the error, the summation error, which is very low, okay, very minimal. Alright, so the next is second question. Okay, you are same, okay, you also same, give the same data, same question. However, for question number C is a challenge for you because y is equal to 1 over c plus dx. What should you do? All right. In this case, okay, you need to do a fractional part by part. Okay, you can do a fractional part by part. All right. It's very easy. All right. To make sure that you can transform to the linear y equal to a plus bx. Don't worry. Actually, we given you a table here. Okay, no need to remember. At least you know how to find. Okay. Y equal to 1 over c plus dx. What should you do? All right, you can find 1 over y equal to c plus dx, where y is a 1 over y, big Y is a y bar, 1 over y, a is a c, and b is a d. All right, so this one is a challenge for you. Okay, this one is also challenge for you. You can do. All right, okay. So now, okay, I hope you can do the exercise. I will try to post the exercise for every group again through the Padlet. All right. So now, where is Jin Enji Shing? All right. Where is Enji Shing? Da. All right. So
Yes, doctor.
he is here. All right. So now, okay, what is a linearization? It's very simple. It's a extend from the linear least square method, where you need to transform from the curve, not linear, to the linear form, to the linear line. All right, that you said just now, you force the data to be a linear. However, the data is a curve. Okay, it's a exponential function. Okay, fractional function, ln function, and so on. All right. Okay, come on. Fill all the questions that I asked at the Padlet to confirm your attendance by tonight. All right. Okay. Any question? Come on. You can go to the chat, top chat, to ask a question. All right. And you can go to the live YouTube. Okay. You can play. You can watch this YouTube again and again because it's always stated in the YouTube. All right. Okay. Bye bye. I'm so sorry again for today because the PhD Viva is take time. All right. It's I think more than 2 hours. All right. From we start from 9 o'clock. All right. So there are many questions. Okay. So to defend the PhD state more, okay, what we expect, okay, because there are so many judges, there are so many evaluators. All right, so any question, Anji Singh? The rest?
Okay,
Okay,
doctor.
Chua Ziong is here. All right, no, doctor. Okay, I hope you clear. All right, thank you very much. Okay, for your um, okay. If no question, okay, so we stop the class. Okay, at
Okay,
12.
thank you, doctor.
Thank you, and just she together with me in this class. All right,
Okay.
bye
Thank you.
bye.
Bye, doctor.